In the old days, CCNA included a topic called VTP, but it doesn't anymore. But you still need to know something about it to survive your lab experience with Cisco switches. In this video, I'll tell you what you need to know. So I organized the videos here at the channel to match the same outline as my books. So in my books, there's a chapter on VLANs and VLAN trunking. The second major section is all about the config details. So I've got 4 matching videos to break it down into smaller chunks here on those same topics. The fourth of those is in this video on VLAN trunking protocol. So in this video, I've organized things as follows. I'll talk about using VTP on purpose. That means using VTP modes server and client. Then we'll talk about the dangers of doing that, which is why most people avoid using it and probably why Cisco removed it from the blueprint. Then third, we'll talk about the way to turn it off using the mode called transparent mode or the VTP off mode as well. And then finally, we'll talk about what's different about what you see in show command output when using VTP with server and client mode and when not using it with transparent and off mode. As usual, if you'll stick around to the end, I'll give you some advice as if you're in the same study group as me, where to focus your study with VTP, which isn't a lot, but I'll point you at a ad hoc lab that I've got here at the channel and also what to do with the book at this point as well. All right, let's go for it. First off, let's review a typical configuration for a campus and focus on the access switches. So these access switches have 1 port each, assigned to VLANs 11 and 12. Between the access switches and the distribution switches, we have a bunch of links and we're going to use trunking on those. But for the access ports here on switch A1, you create VLAN 11 and VLAN 12. We've given it unique non-default names in each of the 2 VLANs as you see there. And then on each of the ports, we configure the switch port access VLAN command to define the VLAN to use and the switch port mode access command to say be an access port. Here we've got VLAN 11 on port 1 and VLAN 12 on port 2. So that's a pretty typical access port configuration. Now let's talk about VTP. So if we look at this alternate version of the configuration, VTP, its goal in life is to distribute VLAN config. Now when I say VLAN config, I'm talking about the highlighted part in the box on the right, the VLAN itself and its name. It does not distribute the switch port access VLAN commands or the switch port mode access commands, those subcommands on interfaces, but it does distribute the VLAN commands because in this design, we want all 6 switches to know about VLAN 11 and VLAN 12, and it'd be nice if they all had the same name in each case. So what you can do with VTP, if you embrace it and want to use it, is make, say, switch D2 what we call a VTP server. VTP servers, by their nature, are switches on which you can configure the VLANs with commands like these. So you get into config mode in switch D2 and you type those commands and then VTP messages flow. By the way, VTP messages flow only over trunks, so they flow over those trunks. So the other 5 switches learn those config commands. So you type them once and the other 5 learn those config commands. So it's a pretty cool idea, actually. And just to talk about the term for a moment, VLAN trunking protocol, the term, it's advertising VLAN global configuration commands and the name subcommand. So that's where the word VLAN comes from. The messages only flow over trunks. That's where the trunking comes from. And it's a protocol. That's where the word protocol comes from. So that's VTP. But don't confuse it as an alternative to the 802.1q trunking protocol, all right? It's a different thing. It's about advertising and distributing VLAN config. So let's talk through some facts on VTP servers and clients. To use it, you'll probably have both. You need 1 or 2 switches configured as servers, and that's where you configure the VLANs. Those servers can also learn VLAN config from others as well. And as I said, it's usually just a couple of switches. Whereas VTP clients, it's all the rest of them. They can learn VLAN config from other switches, but you can't configure VLANs there. Like if you type the VLAN 101 command here on switch A4, if it was a client, the command would now be rejected because you're in VTP client mode. Another fact here is that when you're using VTP servers and clients, when you're making use of it, you can only use the standard mode VLANs, and we see those in this table here. And Later, when we talk about turning off VTP, when you do that, you can use also the extended mode VLANs that are in this range. It's probably a good idea to memorize that table at some point. But it's easy to get reminded of this range because of this deprecated block in the middle. Remember the show VLAN brief and show VLAN command and how it has those 4 VLANs that we can never get rid of and they keep showing up? Well, the standard mode VLANs start at 1 and then go up to 1001 just before that block that always shows up in the show VLAN output. So that's a good reminder of the range of standard mode. All right, so a sample config just to complete the discussion of how to use this on purpose. So if you want to go to lab and try things out, here's what you do to make use of it. Server mode is the default mode if you just grab a switch and start using it without configuring it. But here's how to configure to make it work. You want to set the mode to server or client, respectively, on whichever one you want to use on a switch. But you configure a thing called a domain, and you use the same text value on all the switches that are cooperating. And you configure a password, and you make it the same on all of them. So the only difference between the server and client config is just the mode. You do that on all of them, and now they're set up to go so that on any trunks, they'll send VTP information. On any servers, when they configure a VLAN command, that gets distributed to the other switches. Now, honestly, I went through that config pretty quick, but I don't want you to embrace configuring VTP servers and clients. I want you to see this next section and run away. All right, so here's the deal. Normal operations, which is good. Let's just say we had VLANs 1 through 50 configured. That is, at some point, you configured VLAN 2 and 3 and 4 and so on up through VLAN 50 on one of these VTP servers, and they distributed the VLAN config. So all 6 switches know about VLANs 1 through 50. And then you add the VLAN 51 command, and then they distribute configuration for that. So now all switches know VLANs 1 through 51. That's good, right? But here are the dangers. First off, deletions of VLANs are amplified. So a staff person may not realize the power of VTP and come in and say, hey, I need to delete VLAN 52 over at switch D2. It's or VLAN 32. It's not needed. So they could come up and do a no VLAN 32, not realizing that doing that on a VTP server deletes the VLAN from all the switches. So if we do a no VLAN 32 at the VTP server, it means all the switches no longer have VLAN 32 in them. Now, what does it mean when the VLAN is deleted? Switches won't forward frames for VLANs that aren't defined to them. So at this point, none of the 6 switches would forward frames that arrived on ports associated with VLAN 32. So you might have some access ports on these access switches that have a switch port access VLAN 32 command on them still. The frame arrives and the switch says, oh, this is a frame. It should be in VLAN 32. Oh, whoops, we don't have a VLAN 32. Throw the frame away. All right, so that's what you've done to yourself. So honest mistakes can happen. You train the staff and they, hopefully don't do that again. But here's a particularly crummy honest mistake. Say you've got your production network and all the switches know about VLANs 1 through 50. And then you're over in lab and maybe instead of using VLANs 1 through 50, you're being dutiful, you're using some other VLAN numbers in lab and you've got this lab switch and you're using VLANs 500 through 505. Great. And then you're plugging in cables and you plug in a cable to a wall socket because you think it's, connected over or somewhere in the rack because you think it's connected over to some other part of the lab, thinking you're connecting up lab devices. And what you've really plugged into is a place in the patch panel that connects you over to switch D2. And because you left your options open for dynamically negotiating trunking was established and operational on this link between the lab switch and the VTP server. Interesting, huh? Remember how VTP works on trunks? Well, they'll send VTP messages to each other, assuming you've also enabled VTP on your lab device. And guess what? They have conflicting sets of VLANs. We call that the VLAN database. And depending on some other settings, one or the other will win. So let's just say the lab switch wins that argument. Well, it's going to wipe out the list of VLANs over there in your production network and replace that in all the switches with the list we had over on that lab switch, basically deleting your production VLANs other than the one we can't delete, VLAN 1. Yeah. So it is possible to make an honest mistake in this case and wipe out all your production VLANs. Do you want to use this tool? So that's the reason a lot of people don't. But even if you take this ridiculous case and say, hey, everybody, don't use VTP in lab, or be very, very careful. What about an attacker, right? They know this too. So you've got your production switches that know about VLANs 1 through 50. The attacker comes in with a switch with just VLAN 1 configured in it and VTP configured so that it makes sure to win that argument. It keeps plugging into ports, hoping to find a switch on the other end of a link that's set up to negotiate trunking, create trunking, and overwrite the VLAN database in production, wiping out all your production VLANs and doing a denial of service attack. So these are all reasons why folks tend to say, hey, do we really need to use VTP, or can we just configure the VLANs where they need to be directly on the devices? And that's the option of just not using VTP, which is next. By the way, this video is sponsored by me and my books. If you don't happen to have them yet, and you click that link or scan the QR code and go to my link tree and click the products link there and buy the books there, you don't have to spend any more money, but those sellers happen to give me a few dollars back from the sale. It's a great way to say thanks and support the channel, and I'd very much appreciate it. All right, back to the content. So what we're driving toward is not using VTP. And to do that, one way is to use something called VTP transparent mode. So let me tell you what its original purpose was for just a moment, and then I'll show you how we can use it to turn off VTP. So if in a world where you want to use VTP with servers and clients, it could be that you don't want to use it on a few switches like this one, D9. And if you set it up to be transparent mode, what it means is it'll participate in VTP just enough to let the servers and clients still work, but be transparent to them. So D9 won't learn any VLAN information. For instance, if the server were to send a VTP message, the transparent mode switch, it would forward the message to the client, but the transparent mode switch wouldn't learn anything. All right. It's as if the bottom figure existed where the server, when it sent a VTP message, it would go straight to the client and they really wouldn't have any awareness of the transparent mode switch. That was great for compatibility, but when it got around to saying we don't want VTP, for a long time, Cisco didn't give us an off switch, all right? All we got was this transparent mode. So if you went into your network and configured the VTP mode to transparent for all the switches, you've basically turned it off, because on each switch you can configure directly not only standard but extended mode VLANs. Whatever you configure there is not advertised to other switches, so it's as if you don't have any VTP if you use transparent mode everywhere. And honestly, that's what I've got configured in pretty much every CCNA lab that I've got on my blog site, is turned off VTP using transparent mode, because that's what you can do in Packet Tracer. Eventually, over time, Cisco came up with off mode, where you say don't use it. Now, just to be clear about what its purpose in real life is, if you turn off VTP with the off mode instead of transparent mode, and the server were to send a VTP message, it's off. It won't forward the message. The client on the right would never get the message. So it's not built for compatibility in that case. It doesn't use VTP, it won't process VTP, and so on. It's totally off in that case. But if your goal is to create this network where you're not using VTP and all your switches support the VTP mode off option, turn it off. You would successfully have turned VTP off in your network. You can directly configure standard and extended mode VLANs. You're not distributing VLAN config information. You don't have those big negative dangers when using VTP. So either configure transparent mode everywhere or off mode everywhere to turn off VTP. Turns out you're going to see some different behavior from the CLI on real switches, depending on whether you're using VTP or not. So using VTP, meaning you're using server and client mode to distribute VLAN config. So it turns out that when you use those, the VLAN config is stored in a file. Default name is vlan.dat, and the file is stored in flash memory. So let's just say those VLAN commands were configured at one of 4 switches that we now see. VTP distributes this VLAN.dat file. That's basically what VTP is doing. Its contents are these VLAN commands and name commands to name them, and that represents the VTP messages, say from a server in the upper right, advertising the VLAN.dat file down. Now, all this stuff is in a file in flash memory, and then the switches will use that configuration, but it doesn't show up in the running config file. All right, so if you do a show running config on any of these 4, in this case, you don't see VLAN commands. Now, you do see the VLANs in commands like show VLAN, all right, so that's trustworthy, but sometimes people get into this point where we're using VTP and do a show running config and get confused by the absence of VLAN commands. You shouldn't expect to see them. On the flip side, when you're not using VTP, by virtue of using off or transparent mode, you do see the commands in the running config file. Now, imagine we've got 4 switches again. You type some VLAN commands in the upper right-hand switch. Those do show up in the running config that's stored in RAM, but because there's no mechanism to distribute those commands, it shows no VLAN commands in the running config of the other ones. In other words, you've got to go type VLAN 101, 102, and 103 in the other 3 switches to get those to appear in those switches running config. So you've got to do local VLAN command config on each and every switch. But whenever you type the commands in, it's like any other configuration command. It's stored in running config. If you want to save it, you've got to do a copy run start. It does not make use of that VLAN.dat file, so it's different as well. And you'll get a chance to practice that in the ad hoc lab if you choose to do it. All right, so what do we do with this VTP stuff? Well, there is an ad hoc lab available I'll tell you about here in just a second, but I'm 50-50 on whether you need to do it. VTP is not even in the blueprint, so I think you could have learned enough just from this video to be fine, but if you want to lab it and experiment with it, I've got a lab for you. Then finally, we're through all the smaller videos that comprise the big topic of VLAN and VLAN trunking config, so if you want to use that book section as a second source, now is probably a good time to pull it out and read that. So the ad hoc lab, it's a 4-switch network with a couple of PCs off the access switches and some trunks. And for the exercise, it's basically, hey, make VLANs 101 through 104 exist on all 4 switches. And there are 2 cases, one in which I've configured the switches to be servers and clients. So you'll see VTP in action, and then one where I've turned it off by using transparent mode. So you've got to go through the config there and see differences in like show running config and things like that based on which of the 2 that you're using. And again, use the book, use the section. It's a good section to read through now that we're finally through all 4 of the related videos. Hope you enjoyed the video. If you want a little more, the next video in sequence should appear on the left here. It's about troubleshooting VLANs, troubleshooting all this config we've just gotten through in the last few videos. And on the right, there's a video link to the ad hoc video lab. So check that out if you want to practice with VTP. Hey, thanks for hanging out. I'll talk to you soon.